Hey class, welcome to the final exercise in Chapter 8, Pythagoras' Theorem and Trigonometry. Today we'll be looking at Exercise 8D, Applications of Trigonometry. So, in scenarios, we have what are called angles of elevation and angles of depression, and they're always measured from a horizontal line of sight. So, what that might look like, and I'm just going to do this little note in, let's go with purple, so if I have a line of sight, here is my best attempt at a really quick drawn eyeball. Cute, very terrifying, but that's fine, When I look at things, I usually look straight ahead, If I'm going to elevate, I will look up. So if I have to physically move my head to look up, the angle that makes with my horizontal is the angle of elevation. Think an elevator helps you move up really tall buildings. However, if I look downwards, this would be the angle of depression. Think depression means to feel really low or down, so we're looking down. Also D for down, E is a vowel, and that means up, So depression down, elevation up. The angle that makes with the horizontal, so this bit in here, or this bit up here that I haven't colored in, that's your angle, Always from the horizontal. And I cannot stress this enough. They usually will be the same angle anyway, depending on how we draw the image, but that's a little reminder. We also need to introduce compass bearings for this exercise. There aren't too many questions that cover it, but we'll go through it anyway. So compass bearings indicate a direction between 2 points on a compass. Over here in the black, we've got the compass directions. North is considered 0 degrees straight up. East is 90 degrees, so we've got a 90-degree angle in here. Another 90 degrees going counterclockwise, we get to south, so that's a total of 180 degrees or a straight angle. And then to do the reflex angle here to west, we have 270 degrees. These in here are our true bearings, so we have 0 degrees or the true north, 90 degrees true, 180 degrees true, 270 degrees true, etc. In the orange in between, we've got compass bearings, So these here are true bearings when they have the letter T. If they do not have the letter T, if they are two of the compass directions with a number in between, that's just a normal compass bearing. So this is a true bearing. And in the orange or the red, whatever color that might be, I'm not too sure. We have compass bearings. So what we have in this case, north 45 degrees east, so smack in the middle of north and east. I've traveled from the north 45 degrees to get to the easterly direction. From south in here, I've traveled 60 degrees, sorry, that's 45 degrees. 60 degrees from south towards the east gives me a bearing here of south 60 degrees east, which is the same as 120 degrees true, and that's because this in here is 30 degrees, So the 90 plus 30 gives that 120, or traveling that 60 degrees in. And in here, from 180 to get to 210 degrees true, I've traveled 30 degrees, which is where this number comes from. Of course, that's an extra 30 degrees plus the 180 south, and that's where that 210 comes from. So don't overthink this little bit too much. It's just about practice. Drawing things out and thinking quite rationally will help. But that is a very rushed introduction to compass bearings. We're going to try an example today that will hopefully help explain that a little bit better. So we're going to figure out how tall a tower is. So we've got a tower, and with these, I always suggest that you draw it. So I'm literally going to draw a tower. There's my little tower. It's got a turret, it's got a little window. There we go. Maybe some bricks, like totally up to you how creative you want to get. There we go. I have a cute little... I could have been an art teacher, guys. Alright, I'm even going to give it a flag. YOLO. So there is my tower, and there's the ground that it sits upon. How tall is the tower? So we want to find out how tall my tower is. If the shadow that it casts is 38 meters long, and the angle of elevation looking straight to the top of the tower is 37 degrees. So the angle of elevation, we're going to pretend that I've laid down on the ground, I'm bathing in the sun underneath this tower, okay, and the angle of elevation in here is 37 degrees. So what we'll notice now is that we have constructed a right-angled triangle, okay? So that's my line of sight to the top of the tower. My unknown is x. I've got a length. I've got an angle. We can now do some calculations. So again, we're always going to start by labeling our triangle. Of course, the angle is theta. The hypotenuse we don't have any information on, so I just like to give it a quick cross. The side directly opposite is our x value, or our unknown, and you could give it h instead of x if you'd like for the height, or t for how tall, t for tower, totally up to you what variable you pick, and of course that leaves 38 meters to be our adjacent side. Okay, we now need to substitute those values into the correct trigonometric ratio. So let's remember that O and A, that is tangent. So tan theta equals opposite over adjacent. Remembering, so, ka, toa. So we're using opposite and adjacent, that's our toa. Okay? We'll of course start by substituting in tangent of 37 degrees equals our opposite side x over our adjacent side 38. Of course, to get x on its own, we need to multiply both sides by 38 to cancel out that denominator. So if we enter into our calculator, x equals 38 tan of 37, we get an approximate value to 2 decimal places as per the question of 28.64 meters. Okay, and that's all there is to it. For questions that involve bearings, draw it out, except instead of your triangles being height, they're going to be flat on the ground. So think of, here's a big mass of land, I'm traveling straight across the land, or to the east, whatever it might be. As always, guys, good luck with the work. Let me know if you have any questions, and I will speak to you all very, very soon.